This lecture, we're going to talk about something called the stretch shortening cycle. And it might not be something you've ever heard of, but it's definitely something you've experienced. And so our only objective is just explain how this cycle works. Okay. And again, this might be something that you've talked about in Trevor's classes in like 218, 219, if you've taken that from him. And if you haven't, it's not a big deal. Okay, now with the stretch shortening cycle, there's a neural component, there's a muscular component, and then really when we're describing the actual cycle, there are multiple phases. So I want you to think for a minute. Let's say that you're in a lab or wherever it is, you're outside, and you want to do a vertical jump. So you're trying to see how high you can jump, you're trying to see if you can grab the soccer ball that's in your tree that your kid kicked in the tree, whatever it is. What are you going to do to achieve the highest jump possible? Okay, and so think about that. And what you're going to do is you're going to do a counter movement. Okay, and so what happens is you have a rapid eccentric contraction, which ultimately will activate your muscle spindles. Okay, what happens when we activate muscle spindles? We talked about this during week 4, and the answer is, well, it results in contraction. Remember, muscle spindles activate a muscle. When we activate a muscle, we're causing muscle contraction. Okay, but this neural thing needs to occur quickly. So it's not like you can do this counter movement, hang out for a while, and then get the benefits of it. Okay, and so that muscle spindle is really the big time neural component here. Okay, but it has to happen quickly. This counter movement needs to be quick. Okay, if you don't do it quickly, you're not really activating the spindle, okay, because remember, spindles are activated by changes in length and the rate at which the length changes, okay? So you're not lengthening the muscle that much, but if you do it rapidly, we're going to get some effects. So then we've got this muscular component. So the contraction increases the tension that's in titin. Remember, titin is that springy thing that's on in a sarcomere, and it helps get muscles back to resting length. And so when we stretch out this spring or this titin, we're increasing what's called potential energy. And this is something that we've talked about, and we'll talk about a couple more times as we go throughout the semester. And so this potential energy, just think of it as stored energy. Now, if we go quickly from an eccentric to a concentric contraction, that potential energy or that stored energy in titin is released, and this allows us to generate greater muscular force. Okay, and so now that we've got the neural and the muscular components, we've essentially talked about how this works, but let's go through each of these individual phases. Okay, so with the eccentric phase, remember, an eccentric contraction is where the muscle is lengthening. And so as a result, we stretch out those elastic proteins. So this is titin. And that elastic energy or that potential energy, that's stored energy. And so while we're storing energy, we're also activating a muscle spindle that in essence slows down, cancels out, however you want to look at it, that eccentric contraction. Now, before we can go from eccentric to concentric, there is a period of time where we're not really doing either. Okay, it doesn't last very long, but we've got a transition. And that's what this amortization phase is. It's the transition phase from the eccentric to concentric contraction. Now, in order for us to take advantage of this, like I've said several times, it has to occur immediately. This amortization phase has to occur immediately, or the potential energy is lost. Okay, the way I like to think about this is just imagine if you've got a spring and you stretch it out, and if you just hold it there for a long time, like eventually the spring will lose its spring, right? And it won't recoil as it once did. Okay, now that'll take a long time, where this isn't like that. We can lose this potential energy in a relatively quick, short period of time. All right, and so assuming that we don't take too long, what happens is once we start to jump, we've got greater force. We're increasing those ground reaction forces, okay? So that's us pushing against the ground, because that's what's happening when you're jumping. You're generating force by pushing against the ground, and up you go. And then this leads to the final phase, which is that concentric phase. And so now that stretch reflex that occurs because of the muscle spindle releases that potential energy, and so as a result, we're able to jump higher. We're able to produce more force. So the eccentric phase, we're storing energy as we stretch out the muscle, and that's primarily stored with Tighten. Okay, and then we take that, we amortize that. Okay, and we go from the eccentric to the concentric phase, where that stored energy now becomes actual energy that we can use, so that we can generate more force when we start our jump, and then that transitions into that concentric phase where that energy is released, and we have a bigger jump or a bigger force output. So that's the stretch shortening cycle.